Hello and welcome to Quick Start to Coding with Swift. Please may I introduce my co-host, Matt. Matt Hanlon is a long-time software developer, coach, teacher and dad in Ireland.
Thanks, Steve. And may I introduce Steve Bunce, an author, teacher, associate lecturer, and dad in the northeast of England.
Thanks, Matt. We have an exciting session for you today. Today, we're going to learn about types in Byte's world and learn about how we can change the condition of the portals to turn them on and off. So, it's really interesting to think about how the code is organized and how we can change its condition. Well, we're excited. Let's get started. Hello and welcome to our exciting session today. Today we're going to be thinking about portals and about switches. Now you know about switches because, for example, you might switch something on and off. So you can have a light which you would switch on and off, on and off. And we toggle from being on and off. With Byte moving around the world, can you remember when you used your switches and we toggled these on and we toggled them off? Look, let's watch Byte now. So here Byte comes to the first switch and it's off, so he toggles it on. Now onto a portal, zip, and reappears out the other portal, and then Byte can get the gem. So in this session we're going to be thinking about switches and toggling them on and off, and also portals where you might move quickly from one place to another. So we're going to have fun with portals today. You can use gym equipment or simply write on a piece of paper. So you could write on one saying, this is portal where I will leave, and this is a portal where I will land. Okay, you can try those out. Also, you can make your own switches. So what you can do is you can write on a piece of paper, on one side, and on the other side, off. And when you stand on that piece of paper, you toggle the switch. So it says on, I'll stand on it, and then I'll turn it over, it says off. And later we can have some fun adding some conditions to those. So I think I need to go and try this out. Here's my shirt. I'm off to the gym. I'll see you in a moment. Have fun. Oh, that was tremendous fun, wasn't it? Well, I hope you had fun with portals and thinking about those conditions of them being one portal to go to another and the condition of going from a switch which is on and off. Okay, so have some fun today and I shall see you later. You too can make some jump cuts like that where you use your video, and all you need to do is to stop the video or pause the video and then move to a new position and start recording, and then you can have some magic. It's like you can just disappear whenever you click your fingers.
Thanks, Steve. All right, we're ready to dive into some more coding. Today, we've got a huge concept on our hands. It's called types, which is another way to organize our code. So far, we've learned about functions, where we can group commands, and those will help us organize our code. We've learned about loops. It's another way to organize our code when we identify patterns in our code, and you can loop through them and get the iPad to repeat them. The other thing that we've been introduced to is variables. And that's a way to organize our code because we need to store information so that we can remember it for later. We're going to look at variables today in a little bit of a different context, because today types is talking about how we organize our code and create our own data structures, is what we call them. So it's a way to store a lot more information, but to keep it organized and not just have a loose set of variables floating all over the place, but to say, actually, you know what, this constitutes a house in the game that I'm building, or it constitutes a spaceship in the game that I'm building. So let's open up Swift Playgrounds and take a look. So tap on Swift Playgrounds. We're going to be working with Learn to Code 2, so we'll be continuing on from our Track the Gems exercise. So if I open up Learn to Code 2, we can see that we're where we left off. So we're in Bump Up the Value. Maybe you're a little bit further because you completed some of the extra exercises, but I'm going to tap on here regardless, pull up the table of contents, and go to our types introduction. So in this introduction, we're going to try to figure out how to think about types. And a good way to think of them is as smart blueprints. So if you want to build a house, you would design a blueprint. And now that's not the actual house. You couldn't live in a blueprint. But a type is very like a blueprint for our code. So the blueprint shows you all the features that you're going to have in the house. It might show where certain things come into the house, like electricity, water, and all that kind of stuff. And then once we've defined our blueprint, we can go and make an actual house out of that. So we can give it to a builder and say, okay, cool, let's go build our house. But then we can change certain things like properties on it, like the color of the house, or how many bedrooms it has, or what color the door is. So in programming, we call that an instance of a type. So just like a blueprint is like a type, the actual house that we've built is like an instance of our type in code. So the blueprint shows, like I mentioned, it shows features and behaviors of the house. So some of the features might be things like the color and the number of bedrooms. And then behaviors are things like, I want to run the water in the house, or I want to turn on the lights. The way we would translate that into coding terms is we call those features properties. So you can see here we have our variables that we were discussing yesterday in Track the Gems. We have a variable with the name color, and we assign it a value of green. And in Swift Playgrounds, we can use these little color swatches to determine our color. And then we have another variable called bedrooms, and we've assigned it the value of 2. So those variables, when they're on a type, are called properties. So you might hear the two used interchangeably. On the behavior side, we would call those methods. So we have a method here called run water, and we have another method called turn lights on that we can call on the instances of our type. So you might note that these look a lot like functions, right? They're mashed together words with camel case. So that means that the first letters of each word are capitalized, and they end with 2 parentheses at the end. And that's because methods are just functions that happen to be defined on a type. Now, the way we use these things, like properties and methods on a type, is we have to refer to the house by name. So imagine we've created 3 houses from our house blueprint. Her house, my house, and his house. Now, how would we call a method on my house to open the garage door? Well, it would look a little bit like this. We would use the name of our instance, so my house in this case, followed by a dot, followed by the method name, open garage door. This is what's called dot notation. And just like we can call methods on our instance using dot notation, if we want to access properties and maybe assign them new values, maybe we want to change the color of my house, we would do something like myhouse.color equals, and then we'd give it the new color. We're going to see that in just a second. So in the puzzle world, we're going to be using these instances of portals. And they have certain properties on them. In fact, one of the properties is active. So we can turn them on or off. And you might remember from previous puzzles that when you step inside a portal, it sends you to the corresponding color portal somewhere else on the puzzle. So in the next puzzle, we're not going to want to go through that puzzle. So we're going to want to make it inactive. So let's go take a look. All right, so our goal here is to deactivate a portal, and then we have to solve the puzzle. So as it mentions, up to now, we've been using functions in a very general way. We've been calling move forward or turn left. Those are just functions. They define a set of commands that we want to follow. And they're not on any specific type or instance of a type. So that works well. But as we get more sophisticated with our code, maybe we want to have commands that we can send just to a specific instance. Maybe we'll get to the stage where we have multiple characters on the screen. So we have Hopper and maybe we have Byte somewhere else. We'll see that later in Learn to Code too. So in that case, we wouldn't want to use the general move forward function because who's going to move forward when we call that function? It would make more sense to be able to refer to Hopper or Byte and say Hopper dot move forward. And we'll see that later on in the playgrounds. Not in today's session, but if you keep going on with Learn to Code 2. As we're going through these instructions here, there's a lot of notes about dot notation. So if we tap on that, we'll learn that that's just a form of syntax for accessing properties or calling methods on an instance. So we have an example here where we tell the expert to toggle switch. And it's just calling a specific instance of the toggle switch method that's been defined on the expert type. We have a definition for property, for instance, and a definition for syntax. This is kind of what we've been learning all along. We've been learning a lot of the concepts of coding, but we've also been learning the syntax, which are just the rules for how we write our code. And we have to be very specific in the syntax we use because otherwise Swift won't understand what we're talking about. So here we go. We have the dot notation syntax here. Looks like this: green portal dot isActive equals true. So there's a property on the portal type called isActive that we can set to a Boolean value, which is just one of true or false. So our instructions here say use dot notation to set the isActive property of the green portal instance to false. And then 2, toggle each open switch. Okay, so we have open switches at the end of each of these arms. So how would you solve this puzzle? I'm going to give you a minute to try to think about how you might organize your thoughts in your code. What are the steps we need to take to be able to toggle those switches? Now this is just starting out. Really what this page is all about is it's learning about how to use dot notation and dot syntax to access a property and assign it a new value. We're going to get much more sophisticated later on when we start using types. And in fact, we used types when we were working with lights, camera, code a couple days ago in these sessions. So hopefully as we get introduced to these concepts, you might go back over older material and go, okay, now this makes a bit more sense. Now I understand what a space is. Now I understand what a Swifty camera is. How's your coding coming? All right, well, let's try it out. So first things first, it says use dot notation to set the isActive property to false. So let's change that to false. When I tap on the true value that was being assigned to isActive previously, I have a handy little menu where I can tap true, false. I can delete that or cut it. I also can pick from the autocomplete menu. I'm going to pick from up here. So I've set it to false. Now when I do that, I'm assuming that these will turn off, and I won't, when I step on that, be teleported over here. So let's hit the return key over here. And what do I need to do to solve this? Is there a cleaner way that I could solve this? Well, let's try to just figure it out from the start. So let's see. I'm going to go do move forward, move forward, move forward. Now you'll note that that's, like it mentions above, that's just a function. It's not a method on Hopper or anything. So I've moved forward. I'm here. Let's try turning left and toggling that first switch. So turn left, then we'll move forward, move forward, move forward. That should put us just about on that switch. So we'll toggle the switch. Again, another general function called toggle switch. Now we need to turn around. So maybe we'll turn left twice. We have to move forward 3 times to get back. And I'm going to try running this code. I don't want to write a whole bunch of code and then have something go wrong in the middle. So I'm going to actually try this out early. Now I've already written a lot of code, but let's try it out. So we're running our code. Hopper's going to go. Hopper's going to move forward. Move forward again. Move forward again. You can see that the portal's gray, so I didn't fall into it. I turned left. I'm moving up the stairs. Moving again. Okay, I've toggled the switch. I've turned around. Back I come. Okay, great. I've got 2 more switches to go. That's looking good. So now I might leave a comment for myself. We saw that in the lights, camera, code playground. Let's do that. Let's go hit the arrow here. Now this is the one that we want. So I would tap on C and drag down, or I would hit the button down here in the corner. And now I can just tap on this backslash. I'm going to do that twice. So now this allows me to leave a comment. And I don't have to follow any particular syntax now because Swift will just ignore this. So we'll say solved first toggle there. And then I want to get onto a new line so Swift can start interpreting my code again. So I'm going to hit return and take a look at the puzzle. Now, if you solved that puzzle in a minute, I'm very impressed. Have you gotten to this stage yet? There are a lot of different ways we could solve the puzzle from this point. So I'm going to pause for a second, and if you're at this stage or if you're following along, I'm going to give you a minute to try to catch up, and here we'll bring all the code on the screen, just so that you can have a look and try to see where the patterns might be. Maybe we start to look at patterns already. Can we use some of that code to solve the rest of the puzzle? Or maybe you're thinking, do you know what? I'm actually just going to type out all the lines of code and just solve the puzzle. And then maybe later, maybe tomorrow, I'll come back and I'll try it again. That's also a valid way to do things. All right, so I'm standing there. Hopper's on the board again. That's where we left off. Well, if I turn left again and move 3, so let's try turning left. Turn left. We'll move forward 3 times. So we'll do move forward, move forward, move forward. That should put us here to toggle the switch. So we'll toggle the switch. Then we have to turn around again. So we'll do a turn left and a turn left. I'm here, I'm facing this way, I need to get back, so I'll move forward 3 times again. And then Hopper should be about there. Let's try running that and see what happens. Sometimes I find this is a useful way to solve the problem, is to go through it step by step and just solve little chunks of it at a time. Because that way you can be sure, and it's much easier to debug. If I get something wrong, now I know that this is the code that I want to look at first, because this is the new code that I've just written. So there, Hopper goes up the steps, toggles the switch, turns around. We've got 3 move forwards left. Okay, all right, we've got 1 left. So let's do the same thing. I'm going to bring up the keyboard. I'm going to make 2 slashes because I'm going to leave a comment saying solved, second, switch. And I'm going to hit return, so I'm on the next line. And now to solve this, I'm going to need to turn left again. So here we go. Turn left. We're going to move forward once, twice, 3 times. Should be at the end, so we're going to try to toggle the switch. Perfect. Now the next thing we're going to do is nothing. I think we're done. Now we could have Hopper walk back to the middle and be very complete about the whole thing. But let's try running this and see how it works out. So off Hopper goes, move forward, move forward. Now this is where, as we've done this a few times and we've solved these parts of the puzzle already, this is where we might use our speed. So we might change the speed down here to make Hopper go a little faster. I'm okay with us taking the time though to get through it. There we go, we're headed up the steps. We're going to solve our second one. We turn around again. And then off it goes up to solve that last switch. Perfect. We managed to use our type and our property on our type to figure out how to get past that portal and solve this puzzle. Now, one thing we might do, even though we've just successfully solved the puzzle, is we might go back here and try to reorganize our code a little bit. We see a lot of periods where we're repeating move forward 3 times, move forward 3 times, move forward 3 times. We might create a function where we move forward 3 times. Can you think of another keyword that we might use, or another concept that we might use that we learned about over the last few days to move forward 3 times? Go ahead, throw your answer in the comments if you think of it. We might use a loop, a for loop, where we go through moving forward 3 times. That might save us a bit of typing. We could use a combination of the three. So we could write a little function here and hit the return key. I have the func keyword there, so I'll type func. So we'll call it, whoop, missed that. We'll call it move 3. Notice how I capitalize my T in 3. And we'll use a for loop inside of our function. So it says for I in 1 ... number, we want to do it 3 times. So what number would we put there? Go on, if you're in class, shout it out. It's okay, teacher won't mind. Right, 3. And now all we have to do is type move forward once. So now what I might do is say, actually, anywhere I call move forward 3 times, that's way too many times. I'm going to delete that one. And instead of move forward, I'm going to delete that and start typing move 3. See how it comes up in the autocomplete bar? So do move 3. I would replace all of these. So I'll hit return there and I'll do move 3. Now this is just one improvement we could make to the code. And when I say improvement, it's just in the way that we're organizing our code. So you see I'm going through and I'm replacing all the places where we typed move forward 3 times. And I'm replacing it with one function call. Now, the nice thing about us having commented this at each step of the way is now we can see if there's anything in common between these steps. And maybe there is. Maybe we could do something even better. We have a few turn lefts to turn around. We toggle switch and then we move 3. This is repeated quite a few times, as is the turn left every time we get back to the inactive portal. So I'm going to leave it as an exercise for you, and let's try running this just to make sure that it's still working. This is a bit easier to read in my mind because we've got less commands to wade through, and maybe I accidentally typed 3 move forward or 4 move forwards instead of 3. So there we go. We've solved our first one. So that new function that we created for move 3 behaved the way we expected it to. There we go. We're toggling the other switch, so the second instance worked too. Now, I have a challenge for you. So I'd love to see if you could write this code in the fewest number of lines possible. So you're going to have to use functions. You're going to have to identify patterns and figure out how do I consolidate all of this code, all these commands, into a couple nice groups of code that will help me solve this puzzle really efficiently. So you can see we didn't solve it in this case because we're missing that last one. And we didn't solve it because I hit stop early. So let's have Hopper solve it. We'll run fastest, see how Hopper does. And I want you to go and try to make this even more efficient, or to use a function of your own to see how you would organize the code. Because that's what it's all about, especially with types and being able to do things like set properties on those types and change how they behave. All right, hope you had fun today. Let's go talk to the guys